Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up another numerical on quantization. Please note this is one of the previously asked MSc numerical. Let me read out the question first. A sinusoidal signal with an amplitude of 3.25 volt is applied to a uniform quantizer of the mid-riser type whose output takes on values plus or minus 0.5, plus or minus 1.5, plus or minus 2.5, plus or minus 3.5 volts. Sketch the waveform of the resulting quantizer output for one complete cycle of the input. Right. Please identify what is being asked in the question. We are asked to sketch the output of the quantizer for one cycle of the input. Let us start with the solution part. Let me write down what is being given in the numerical. We are told there is a signal of amplitude 3.25 volt. Then we are told the type of the quantizer is mid-riser quantizer. Further, the output values of the quantizer are given as plus or minus 0.5, plus or minus 1.5, plus or minus 2.5 and plus or minus 3.5 volts. Please note these are nothing but the representation levels or quantization levels of the quantizer. Right. This is sufficient enough to sketch the output of the quantizer. Let me start with that part. I have changed my layout here because using this layout would be much easier for me to draw a very scaled diagram. I will start with the transfer characteristic of the mid-riser quantizer first. We are told the amplitude levels of this quantizer are plus or minus 0.5, plus or minus 1.5, plus or minus 2.5 and plus or minus 3.5. So, let us mark those values here. Okay. Let me now start plotting the transfer characteristic. As we are very clearly told it is a mid-riser quantizer, I have to start by plotting a riser on the origin. By looking at the y-axis here, you can identify the step size of this quantizer is 1 volt because any two discrete sample values differ by simply 1 volt. So, after plotting the riser, I have to now plot a tread which is also for 1 volt. Then we have another riser here, then we have another tread, another riser, another tread. Continue in this fashion. Coming to the x-axis values, this line here is this is 1, this is 2, this is 3, this is 4. Similarly, we have minus 1, minus 2, minus 3 here and lastly minus 4. This is the transfer characteristic of the mid-riser quantizer. Let us now plot the input voltage waveform which is a sinusoidal signal for one full cycle. Please note I will be plotting it just below the quantizer transfer characteristic because I want to match the voltage axis of the input with the input axis of the transfer characteristic of the quantizer. Okay. We are told the sinusoidal signal has an amplitude of 3.25 volts. So, I will first mark the input signal amplitude values. So, let us plot the input voltage waveform itself which is our sinusoidal signal. Please note it should have an amplitude of 3.25. Okay. This is our input signal for one full cycle. Let me now connect the input signal waveform with the transfer characteristic of the quantizer. because that would make it very easier to plot the quantizer output. Right. You can now see that the x-axis, which is the input voltage axis of the transfer characteristic of the quantizer, is very well matched with the voltage axis of the input signal. Now we can start plotting the quantizer output. I'll start with the x-axis of the quantizer, which is the time axis, because please note we are asked to sketch the output waveform. So the x-axis is time axis, y-axis is the output voltage, which is again in terms of volts. Now we once again have to connect the output of the quantizer diagram with the representation levels of the transfer characteristic of the quantizer. Let me do that now. I'll mark the y-axis values here. Okay. Now, as per the quantization, a value of input amplitude range varying from 0 to 1 volt will have an amplitude of 0.5 volts across the output. So, you come back to the output of the quantizer, which is this diagram which I am currently drawing, and from 0 to 1 volt you simply plot a value of 0.5. Then the amplitude changes from 0.5 to 1.5. Once again we have a horizontal line here, and then it continues in this fashion for the rest of the half cycle. Now you follow the same pattern for the negative half cycle. Right. This is the output of the quantizer. Let me mark all of these waveforms here. As I said, this is the quantizer output. This is the quantizer input, and this is the transfer characteristic of the quantizer. Right. So that completes the solution for this numerical. Well, if you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.